Math 2, Unit 10, Section 6, Fractional Exponents. So looking there today, we are going to be talking about fractions. Don't get too excited. As a reminder, during notes, everyone needs to be actively taking notes. Do not have out your cell phones during notes, and refrain from talking so that everyone can hear this video. Okay, so with fractional exponents, if you notice here, and on your papers it might be hard to see, but this is saying 9 to the 1/2. Okay, so 9 to the 1/2 is the same thing as writing it in a root. So we're going to kind of do this here to the side. If I have 9 to the 1/2 power, the 1 actually will end up representing your exponent, and the 2 represents your root. So if I were to rewrite this in root form, I would make a root. This 9, the base number, goes inside the root. The root is a 2. Now normally we do not write a 2 for the root, but I'm going to write it here on this one. So this means that we're going to have a square root. And then once you get the answer to this problem, you would end up raising it to the first power. So oftentimes when we see something such as this, 9 to the 1/2 power, we really would just write it as the square root of 9. Okay, and then the square root of 9 can be simplified, and that is going to equal 3. Because we know that 9 breaks down to 3 times 3, so we have a pair of 3's, which makes the answer 3. In the same aspect, if you look down here, let's see here, they have 8 to the 2/3, it looks like. And so when you rewrite that one, again, remember that this bottom number is your root, and the top number is your exponent. And so when I rewrite this one, it would be the cubed root of 8, because that 3 goes for the index in your root. And then once you get that answer, you would raise it to the second power. So that power comes from that number on top. So the cubed root of 8, what does 8 break down to? Hopefully you remember this one. We've talked about a lot, 2, 2, and 2. And we talked about this 2 previously in our notes, but when this index is something other than 2, that's how many you need for your group. So this is saying that we need 3 for a group. So if you look here, there is 1, 2, 3 2's. So that means that the cubed root of 8 is 2. And then because we have that exponent out here of 2, we'd go 2 squared. And so this answer would end up being 4. Okay, so we're going to start working through a few more examples here. So on example 1, x to the 1/2 power, that means that the 2, again, is my root, and the 1 is my exponent. When we make a root, a 2 can be written here if you want, but we talked about how with square roots, we don't usually put the 2 there. So if it doesn't say a number, we know it's a 2. And so I'm not going to write it. And then we have x. And then if you are taking something to the first power, it's not going to change. And so I'm not going to write the 1 either. So that's your answer. But if you want to write the other way, I'm just going to show you. It's the same thing as having the 2 there, the x here, and then raising it to the first power. Sometimes too, they might put the first power here with the x. Either way, it will work out the same. Okay, so those are our answers. All right, number 2. So what will be the index for the root on this one? Okay, so hopefully you said 6. So 6 is our root number. So that means I would need 6 terms, 6 of the same thing in order to make a group. And then we have a, and this can be written to the 5th power. That is one way of writing it. What I was saying before, and in this case, this might be a better way of writing this one. We have the 6th root of a, and you can also have to the 5th power in there. These mean the same thing. Since I can't find the 6th root of a, I'm not able to raise it to the 5th power, and even if I have my 5th power in here, a to the 5th isn't going to give me 6 of anything. So either one of these answers is acceptable. Okay, number 3. Okay, my root on this one is the cubed root of 2. And again, the 2 can go on the inside or the outside. So I'm going to go ahead and write it both ways. So if we go the cubed root of 2 squared, or it can also be written as the cubed root of 2 to the 2nd power. Now, on your homework, when you're completing some of these problems, and actually this could also be written as the cubed root of 4, because 2 to the 2nd power is 4, and that can't be simplified any further. All 3 of these answers will work. Do you need to write all 3 of the answers? No. Whichever method you like or makes the most sense to you, write your answer that way. Okay? All right. So this next part is just showing you that if you have a problem written in root form, you can change it to exponent form. Okay, so again, this number right here is the number that is always in the denominator or bottom. And this number right here is always in the numerator or top. And so when this gets changed to exponential form, so we're writing instead of in root form into exponential form, it is rewritten as b to the 3/5, because this number needs to be the number that would go into the root, and that is the number that is your exponent. Okay, so we're going to turn to the next page. So on examples 4 and 5, they just want you to change those into exponential form. Now, if you look at 4, there is no number in the index here. So we know automatically if there's no number, it's a, hopefully you said 2, okay? And so when I write this, our index value always goes in the denominator. If there isn't an exponent value, we know that that is also going to end up being a 1. And so this in exponential form is x to the 1/2. So I'm going to give you about 10 seconds to rewrite number 5 in exponential form. Okay, so on number 5, you should have written that as 2 to the 3/4 power. Okay, moving on now to 6 through 13, they actually want us to simplify. Okay, and so we're going to change these into root form and then simplify them as much as possible. What would be my I started giving the answer. What would be my index for number 6? So the index would be 4. It's a 4th root, because 4 is the denominator, of 16. I do not need to write this to the 1st power because it wouldn't change an answer. So anytime we have a 1 up here, we just have to write the root and we don't have to write the exponent. What numbers does 16 break down to? Should be writing 4 times 4 makes 16. Each of my 4s can break down to 2 and 2. And so we notice that we have to have 4 for a group, and right now I have exactly 4 2s, so I have one group of 2s, which means that my answer is just 2. Okay, I'm going to give you about 20 seconds here to try example 7 on your own. Okay, so on 7, you should have written the cubed root of 27. Again, this tells us our root number or our index number. It's being raised to the first power, so I don't need to do that. 27 breaks down to 9 times 3. 9 breaks down to 3 and 3. Because my index is 3, that tells me I need 3 for a group, and I have exactly 3 3s, so that means my answer is 3. Okay, number 8. Number 8, what will be my root? So hopefully you're saying the root number is 2. Do I need to write a 2 here? No. Okay, if you want to write a 2 here, you are welcome to. It just is unnecessary. The number that goes in here is 25. And then this time I have a 3 for an exponent. So I'm going to go ahead and write this to the third power. The square root of 25, that means I need 2 for a group. And so if I break 25 down, that's 5 and 5. So I have a group of 5s. And so I end up getting 5 to the third power. And if we multiply out 5 to the third power, that makes 125. Okay, number 9. What will be my index on number 9? Okay, so hopefully you're saying 3. So that means we're taking the cubed root of 27. And then once I get that answer, this one's being raised to the second power. So remember, my exponent is up there. The bottom number is the index for my root. 27, we've already broken this one down, but we'll go through it again. This is 9 times 3. And then 9 is 3 and 3. So I need 3 for my group because my index is 3. So I have 3 3s. So that means that the cubed root of 27 is 3 because there's only one group. And then we're raising that to the second power because of my exponents there. And so 3 to the second power is 9. Okay, I'm going to give you about 20 seconds here to try number 10 on your own. Okay, so the answer you should have got for number 10 was 16. Okay, when we write this one out, it's the cubed root of 64, and then we end up raising that to the second power. 64, I would break it down to 16 times 4. If you did this a different way, that is fine. Okay, and then 16 breaks down to 4 and 4. I need 3 for a group here because of my index, and I have 3 fourths. Some of you might have broken it down where you got 2 different groups of 2s, okay? Which is also fine because when you end up bringing out your 2 groups of 2s, you multiply them together and you get 4. My way, I just got a group of 4s, so I have 4 to the second power, which makes 16. Okay, number 11. We have 25 to the negative 1/2 power. Hopefully you remember that anytime you have a negative exponent, you have to change sides. So in this case, we end up having 1 over 25 to the 1/2 power. So the 25, the negative 1/2 is touching the 25. Just like when before if we had, I'm just going to show you a little side example here. Remember when I had, let's see if I had x squared y to the negative 1/3. Well, when you have a negative exponent, that part goes to the denominator. And so that would have been x squared over y to the 1/3. In this case, 25 is touching the negative 1/2, so the whole part goes down to the denominator. So when we rewrite this one now, we're going to have 1 over the square root of 25. Now this could end up being a problem if we still have a root in the denominator. We'd have to rationalize it. But it looks like if we simplify this and does 25 break down, the answer is yes. 25 breaks down to 5 times 5, so we have a pair of 5s. And so this answer ends up being 1 over 5. So just be careful when you see negative exponents. You're going to have to move that to the denominator. Okay, so the same thing is going to happen here on number 12. So I have a negative exponent again. So I'm going to rewrite this as 1 over 9 to the 3/2. We want to get rid of that negative exponent first. Next, I can rewrite this. We have 1 over the square root of 9 to the 3rd power. Again, I didn't write my index of 2 because that's my root right there, my index number. If you want to, you can. 9 breaks down to 3 and 3, so I have a pair of 3's. We end up getting 1 over, since I had a pair of 3's, that's my group, and we take 3 to the 3rd power. 3 to the 3rd power is 27, so my answer is 1 over 27. 13. I have 2 negative numbers here. One of my negatives is with the 64 and one of them is with my exponent. The number with the exponent, the negative here, is the one that we have to get rid of. When we're getting rid of this negative, it doesn't affect this negative. So we're going to rewrite this as 1 over negative 64 to the 1/3 power. When we rewrite this with the root, we get 1 over, and this is the cubed root of negative 64. We haven't talked about this a lot, but anytime you have a negative number under an odd root, odd numbers meaning 3, 5, 7, the answer just comes out as a negative number. Because if you were to multiply 3 negatives together, like -2 times -2 times -2, that ends up making a -8. So a cubed root with a negative under the root will give you a negative answer. So 64. I think we actually did this back on example 10. When I did it up here, you can see how 64 broke down to 4 times 4 times 4. So I'm going to go ahead and just do that. 4 times 4 times 4, or even if you wanted to, you could go -4 times -4 times -4. So we have 3 -4s. And so I end up with 1 over -4 as my answer. Okay, moving on, number 14. It says simplify and leave your answer in radical form if necessary. So we're going to change it into root, and if there is a root left over in our answer, we will leave it that way. Notice here the 1/2 is touching the 25 and the x. So that means when I make my square root, the whole 25x is going to go under the root. So we're going to take the square root of 25x. Then we want to simplify. 25 can break down to 5 times 5. So I have a pair of 5's. And x's, there's no group for the x's, so that's left over. We box that. And this answer is 5 root x. (15). Okay, this whole group is in a parenthesis to the 2/3. So we rewrite this. This is going to be the cubed root of 8d, and then it's going to be squared. So when I simplify this, 8 we know breaks down to 2, 2, and 2. Since this is a 3, we know we need 3 of the same numbers. So I have that as a group. D is left over inside. So when I write this, I'm going to have 2 and then the cubed root of d. Okay, and that's being squared. When you square something, you have to square everything inside. So we're going to have to square that 2, which makes it a 4. This stays a cubed root. That 3 isn't really a number, it's just our index. And then we would also square the d, and that makes that d squared, but still doesn't give us anything to take out from underneath the root. And that's my final answer. Okay, moving on to number 16. Okay, on 16, again, we're going to rewrite this This will be the cubed root of 27 x to the 6th, y to the 3rd, and once we get that answer, we can raise it to the 2nd power. 27 breaks down to 3 times 3 times 3. We've done that one a lot already today. So I have one group of 3's, because again, 3 is my index. X to the 6th, I'm going to break in groups of 3, so we have x to the 3rd and x to the 3rd. Nothing left over, and we have a group of y's. Y to the 3rd, nothing left over. So when I bring that out of the root, I end up with 3x squared y, and then this is being raised to the 2nd power. So from there, we need to simplify and square everything in the parentheses. So 3 squared makes 9. X squared to the 2nd power, we multiply powers to powers. 2 times 2 makes x to the 4th. And then we have y squared. And that is our final answer. Okay, on this last one, we are just checking or trying to figure out what x equals. And so if you look here, we just want to make these bases the same, or the bases are actually already the same. So I'm going to change these to a fractional exponent because that's what this answer is over here. So I would write this as 81 to the 2/3, because remember, this is my top number, my exponent, and the 3, the root or index, always goes in the denominator. Times 81, and this one's going to be 8/3. So in order to figure out what x is right here, everything's already the same. Both of these are already 81s. The bottom number is already a 3 for our root. And so what do we do when we're multiplying? What do we do with our exponents? Hopefully you said add. That is correct. So all I'm going to do is add my 2/3 plus 8/3, and when I add that together, I get 11/3. So if you look here, that means that it's 81 to the 11/3, and therefore x will equal 11, should be the answer, because that 11 is what is missing in the spot for the x. Okay, 18. We have 2 to the 3/5, and here I have 2 to the 4th with an index of 10. So I'm going to start by changing this so that it is in exponential form, okay? And so that means this would end up being 2 to the 4/10, because 4 is my exponent and 10 is my root number. Now I notice all of these have denominators of 5. And looking at this, I could actually reduce it to have a denominator of 5. And 2 or 4/10 you can reduce by 2, and you get 2/5, or 2/5. So if I rewrite this problem, I have 2 to the 3/5 divided by 2 to the 2/5. And if you remember, when we have dividing, we don't add the exponents, but we subtract the exponents. So that means I'd end up taking 2 to the 3/5 minus my 2/5, and 3 minus 2 makes 1/5. And so based on this, we end up with 2 to the 1/5 equals 2 to the x/5. So that means that x has to equal 1. Hopefully you said 1. Okay, if you have any questions, feel free to ask.